Et dans un instant, Tom et Marcus reviennent pour nous présenter la prochaine grande tendance tech identifiée, celle de la nouvelle ère des neurotechnologies, pour augmenter l'esprit humain d'une part, mais aussi pour apprendre à décoder jusqu'à lire même dans les pensées, vous allez voir.
Hello again.
Hello again. Time now for our next chapter of award-winning innovations. This next chapter is entitled Mind Your Brain, and you'll soon see why. Marcus, who's here with me now, we've talked lots about neurotech and brain interfaces over the years, haven't we? It's very much on our radar.
Absolutely. It's been fascinating to follow all the progress that's been made in the area of the brain, in the area of the mind. You may remember, some of you, back in 2018, we had an innovator from Australia who created a device called the Stentrode, which is a tiny electrical device placed just under the scalp that picked up on people's brain waves and enabled, for example, paralyzed people to command devices to use computers just with their thoughts. There's a person that's been testing that for nearly 2 years now. It's been living with that, and it's totally transformed their lives. And I'm sure you remember last year we had a major section on repairing the brain with 2 fantastic award winners, the NIR project from the CA in Grenoble, which put a little implant inside the brain that emits near-infrared light, which can slow down neurodegenerative diseases. And also we had another innovation from Spain, which you just wear a cap and it selectively stimulates parts of the brain with electrical signals and helps to prevent epilepsy and probably even depression. That's in clinical trials now, so that's very promising. But this year we're looking more at the mind. Instead of repairing the mind, in this case, we'll be looking at understanding it.
Yeah, it's absolutely incredible. I mean, imagine being able to turn your thoughts into texts. Now, it sounds like the stuff of the future, the stuff of science fiction, but it isn't. It's a reality. It's called D-Wave. They use a special headset, and it decodes the brainwaves, turns them into texts. And the possibilities for how this could be used are absolutely endless. So to find out more about it, I spoke to computer scientist Chin-Teng Lin from the University of Technology, Sydney, that's UTS. He developed D-Wave, and I started by asking him to tell us just a bit more about what it is.
In a nutshell, D-Wave is an AI model for translating human brain signals into readable English sentences. So unlike the human computer interface by Neuralink, for example, our D-Wave method is targeted on non-invasive BCI sensors, which do not need to perform surgical implementation. So essentially, when this technology becomes more mature in the future, it's safer for the user to use. Also, our D-Wave method combines the state-of-the-art machine learning method with large language models to achieve a good translation performance. So we consider the D-Wave is a technique breakthrough in the BCI area, as we are the first models to decode language directly from non-invasive brain signals.
And so because this method is non-invasive, we can imagine many different possibilities for this innovation. What kind of applications are you considering?
Yeah, you are absolutely right. Medically, this branch of research aims at helping people with brain injury, spinal cord injury, paralysis, or lock-in syndrome to regain some ability to communicate with the outside world, which believe would make their life easier.
What would be another application outside of medicine?
So actually, we have bigger ambitions and expectations for this technology, as EEG caps are non-invasive, portable, and relatively easy to use. So we believe broader applications in the social communications domain can be the area where this technology could shine, and it is more developed, as it is more developed. So which means in the future, it is possible to test your friends to send tweeters using only brain signals to give commands to control devices using your thoughts.
Do you think people might be a bit scared that there's like a privacy angle to this, decoding someone's thoughts with no filter, perhaps? Is there a privacy concern?
Yeah, they do have just kind of concern in general for the brain-computer interface technology. But for this, the technology we develop, so we emphasize is the portable and mobile. So actually, with all the signal processing happen just on the head, on our headset.
How accurate is it? Do you get sort of a clear word-for-word set of sentences that coming out of this technology, or does some of it get a little bit confused and a bit garbled?
Yeah, you are correct. So it is not entirely accurate at this stage, and there is much room to improve. So, and you are absolutely right about the noisy nature of people's thoughts. So, for example, when we always have some sneaky conversations inside our brain, inside our mind, even when we are presenting in a very formal speech. And most of the thinking in our brain is not even a complete sentence, right? So the way only present a primitive result in this research area.
Okay, and does the technology work really well in some areas or on some subjects and not so well in others? If so, what topics or words does it struggle with, and what topics or words does it excel with?
Okay, currently the technology actually rely on the power of the large language models to structure noisy keywords or signals from the human brain into readable sentences. So the D-Wave method is good at decoding a sentence, but still struggle to decode the precise word once at a time. So this is a limitation that we plan to address in our recent and future research.
So with all the many possibilities for this innovation, how do you envision to scale up in the future?
We want to scale up in several ways. Yeah, for example, right now the accuracy, we want to further enhance accuracy at the moment. Right now, accuracy is around only 50 to 60%. So it's not so practical in some applications. So we want to enhance accuracy. So there are several ways to enhance accuracy. Several approach. For example, we want to limit the number of words and also the number of sentences in some specific domain. For example, in the domain of the home care, in the domain of the smart home control, something like this. So we limited the domain, and actually our original result is quite good. We can enhance accuracy as high as 80%. Of course, for such an application, the user are limited to some kind of sentences in some domain instead of natural language. The second second effort that we are doing is that we are trying to pursue for a personalized application, a personalized model. So through I call it the neural feedback technology. So somehow it's kind of cross loop. So we have when the user used our system, then the system and the user, they will learn each other. Yeah, so different people, I think, have different ways of speaking, especially in the brain. So not only we train the AI, but the human will also tune his or her way speak, and it's just that both then can enhance each other and to reach the higher accuracies. Yeah, so this is some efforts we are working on.
Okay, well, thank you very much indeed for your time. Thank you, Dr. Lin.
Okay, thank you for your time. Yeah.
It's pretty amazing that, isn't it? Turning thoughts into text. But I repeat that same question I put to Dr. Lin there. Isn't there a bit of a concern this type of technology could be misused, Marcus?
Well, there is. I mean, in this case, this is a light local device, so no one else needs to have access to it. And of course, all the people in this program are volunteers. But let's imagine a possible future when some tech giant manages to sell us a headset for virtual reality or something that we strap on our face for most of the day. And then they work out a way for that to interpret our brainwaves and our emotions to sell us more things, to be even more invasive. That may sound like science fiction, but now we're realizing that it's really not a very long way off the day when some aspects of our mental privacy will be invaded, and there's even been some legislation to prevent this in the country of Chile, which has been very forward-thinking and has added a neuro rights provision to its constitution, which guarantees the right to mental privacy. It guarantees citizens against having their emotions or thoughts read against their will. Now, a few years ago, we thought, well, this is very smart, but it's not really happening yet. But now when we're seeing technology like this and other efforts, we're seeing this new age of neurotech. Maybe that is just around the corner.
Okay, well, thank you for that. Remember, you can vote for that innovation, D-Wave, by scanning the QR code that's just there. We'll be voting, obviously, at the end of the day on all of the innovations, 10 in all. We've seen 4 so far. Up next, Julia is going to be back talking about a citizen initiative at UNESCO.